We're going to continue with the questions. The next one, you are asked for a method to describe how you would carry out the above reaction at different temperatures, measuring the rate. You can see you're forming a solid, and they do indicate in the question that they want you to use the disappearing cross method, and you're going to do that at different temperatures. So what I'm going to say is I'm going to say mix the reactants, okay, and you're doing this at different temperatures, so you need to specify how you're going to do that at different temperatures. So how are you going to heat them? So I'm going to say mix reactants and place beaker in a water bath set to different temperatures. So some way that you're going to change the temperature. You can talk about a hot plate, you can talk about a Bunsen burner, but just some way that you're going to control the temperature of the reaction. And place beaker in a water bath set to different temperatures. Must, tell me what you're going to keep the same. Must keep mass / volume of reactants the same. So that's what you're going to keep the same. You're not going to talk about keeping pressure the same because you're not reacting gases. So keep the mass, the volume of reactants the same. You could say keep concentration of reactants the same. You need to give me something that you are going to keep the same. And then you're going to tell me how you're going to do it. And you need to mention time. So say how you're going to record the time. You're going to use a stopwatch to record time for precipitate, which I'm going to abbreviate PBT, to form. Okay, you're forming a solid. The reaction is going to become cloudy. It's called a precipitate. And you're going to record using a stopwatch how long it takes for that precipitate to form. You need to mention what you're keeping constant, and you need to mention how you are going to control that temperature change. So that's where your 3 marks are coming from. For the reaction, so the easy bit, I'm going to fill in the carbon dioxide, CO2, and the water, H2O. You also need to do calcium chloride. Calcium is in group 2, so it's going to have a 2+ charge. Chlorine is going to be in group 7. It's going to have a -1 charge. These charges need to balance. I've got 2 positive charges. That means I need 2 negative charges. So I need 2 chlorines, and I'm going to write it as Ca, Cl, and a little 2. I'm using a small 2 because it's a chemical formula. They're actually bonded to each other. So once I've drawn this all out, that gets me 1 mark. So if you got that right, you get 1 mark, and you get a 2nd mark for balancing it. So if I have a look at how I'm going to balancing it, straight away I can see I've got 2 chlorines on this side. I've only got 1 on this side, so I'm going to need to put a 2 there. And then if I've done that, I've got 2 hydrogens, I've got 1 calcium, 1 carbon, 1 carbon, 3 oxygens, and 1, 2, 3 oxygens. It is now balanced. 2 marks if you got that balanced. State how the graph shows that line B gives the results for the larger marble chip. So I've got line A and I've got line B. Line B is less steep. And I would expect the larger marble chips to be to give me a slower rate of reaction. So I'd expect the line to be less steep for the larger marble chips. A tangent has been drawn. Calculate the rate of reaction at this point. So again, they've drawn the tangent for you. And they've also drawn you this handy little triangle, which makes it really easy to pick points. So I'm going to pick the 2 points at the end of the tangent because I think they're the easiest points to pick. This one over here is going to be 0 on the x-axis, and it's going to be 30 on the y-axis. And then up top on the y-axis, it's clearly 90, and on the x-axis, what's that going to be? I'm going up in 2, so that's 62, 64, 66, 68, 70, 72. So it's 72 and 90, and then I had 0 and 30. So my change in y, on my y, I'm going from 90 to 30, so my change is going to be 60. My change in x is going to be 72 minus 0. My change in x is going to be 72. 60 divided by 72 equals 0.83. Okay, that's going to be your answer. During any reaction, reactants are used up and the rate of the reaction decreases. Why does the rate of the reaction decreases? If you've got less particles, you have got less frequent, use that word frequent, collisions. Okay, so the reactants are being used up. That means you've got less particles in there, less frequent collisions, and you are going to get a decrease in Great. So you'll get 1 mark for telling me there's less particles and another mark for telling me that there will be less frequent collisions. Which shows the mass of the catalyst. The catalyst does not change over the course of a reaction, so it is going to be C. The mass is going to stay exactly the same over time. It's not used up. It doesn't change. Moving on to E, they give you 2 different reactions, experiment 1 and experiment 2. Between experiment 1 and 2, they change the temperature and they change the pressure. And then they're asking, why is it not possible to predict what the rate of experiment 2 will be compared with experiment 1? Well, let's look at the changes that they have made. In experiment 1 to experiment 2, in terms of the temperature, they have decreased the temp. And if they're decreasing the temperature, we would expect a decrease in the rate. And then we're going to look, using my sparkly pen, what they have done to the pressure. So they have increased pressure. You're going from 1 atmosphere to 2 atmospheres. And if you're increasing the pressure, you would increase the rate. So you're trying to compare reaction 1 to reaction 2, experiment 1 to experiment 2, but you're decreasing the temperature, so you're going to decrease the rate, but at the same time you're increasing the pressure, so you're increasing the rate. So you don't know which one, the temperature or the pressure, is going to have a greater effect. So you don't know if you are actually going to slow this reaction down because you've decreased the temperature, or speed the reaction up because you've increased the pressure. So that, I'm going to switch back to a non-sparkly pen, is what you are going to say. You're going to say that basically what I've just written, that the decrease in temp from experiment 1 to experiment 2 will decrease rate. The increase in pressure from experiment 1 to 2 will increase rate. Cannot tell which will have greater effect. So don't know if rate will increase / decrease. Okay. Oh, I'm done. Oh, this is actually a relatively short video. Any questions on any of that? Some of it I might have gone through quite quickly. Please just message me. Again, if you want me to read your 6-mark question, take a snap of it, send it on to me. If you got any questions about the graphs, if you're not getting them to work out, let me know. I'm going to attach the mark scheme on for you next week as well, so you can have a look at the actual mark scheme answers. But in the meantime, any questions with any of it, if you want me to read any of your longer answers, then take a photo of it, email it to me, and I'm happy to have a look.